Welcome to Speakeasy JS, the JavaScript meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this evening. So mad science is about doing things for no other reason than because you can, building things that make people say, whoa, I didn't know that was possible. Today's talk is from Rafael Specht, who will be talking about a gift of sound and vision, affecting images using the Web Audio API. And I'll go ahead and introduce Rafael now. You want to say hi?
Hi, everybody. It's pretty nice to be here. It's a real pleasure.
And we're also joined by a panelist, John Heisey. You want to say hi, John?
Hello. Good to see everybody. I'm really looking forward to this talk. Just the slides look really cool.
Nice. Yeah, it's going to be great. So Rafael is a developer from Brazil. He's a Web Audio API enthusiast, and he was once called a weird web wizard at a conference, and I think that's totally appropriate given the subject matter of your talk today. And we're taking kind of a change of gears from our talks over the last 3 weeks, which have mainly focused on security and on package management and how to keep your dependencies secure. Because this week's talk is all about video, audio, Canvas, and all kinds of cool audiovisual experiments. So I'm really excited for your talk, Rafael, and you can go ahead and take it away if you're ready.
Thanks so much. Is my slides live? Okay, now.
Yeah, they're live.
Talking. So it was 1975. David Bowie released this really awesome masterpiece. It's one of the coolest things in music at all. And on this great album, you have Sound and Vision, the song where he speaks about a gift of sound and vision. And today I will prove that he was meaning like speaking of and singing about our modern APIs. The first one that we will tackle is the Canvas. It's a pretty powerful API and thing that you can do. One of my favorite features, and it's basically you can load an image, and once you load it on the callback, you can you call the get image data and have information pixel by pixel of the image. So you have the red, green, blue, and alpha in this big array. And but if you grab this array in the original form and you plot, you have like something that looks like a saw, and it's not very useful. Even if because you have the alpha value that is it's like the same to every pixel and not really useful. But even if you remove alpha, you have values that are like in sequence that are not close to each one in a useful way. But once you go through the array and you split each color, you have awesome information that you have the red, green, and blue of the you can go line by line, and this is the line the first line of the image. And one cool thing that you can notice here, the colors go down together because you have this close to black part here in the top. And this is line 200. I think that you have like wider black part because his coat. So you can see the coat here is causing these colors to drop together. And now you have pretty useful information line by line, or you can plot this in the way that you want. Doing a quick shift, just remember that you can store, you can grab colors as arrays. And the Web Audio API, the sound part of the song, you can do many cool stuff. But you basically, the way that you interact with this API, you basically have these nodes that has specific functions, like you have a delay oscillator, you have the media one to use your microphone. And the way you create this chain of signal that goes from a source, or like can be a song, can be your microphone, to the speakers. And we have these changes, these nodes here that I will talk more about later. One of the coolest is the buffer. A buffer is basically a node where you can write wherever you want. So here we are creating a scene function with 300 hertz of frequency. And it's kind of boring, like when you play it, but you'll see. But this is the thing, you can fill an array with the values of this function, and you can create a node buffer source, and then you write the array content inside the buffer, and you connect to your speakers. Once you do this, you can basically play a function. You can, if you have a favorite math function, you can, let's hear how my favorite function will sound. And so if colors, like if you can grab any array that you want and play, this means that an array can sing, and you're about to listen these. Like here we have this function, the 300 hertz scene, and mind your, like if you're hearing on phones, just be aware, mind that we are playing some annoying stuff tonight. So here is the, I'm sorry, this should be full screen. Let me restart something to see if it will fit together. So let's see. Yes, now it's full screen. Okay, and so this is 300 hertz being played. It's annoying, I know, and this is a different way to be annoying on the internet. See, and you can do this with 600 hertz. Let me do this again. So yeah, you can wherever you want. So you can play wherever you want. And if you do this with a decreasing exponential and with a scene, you have pretty much a beat. And you can do this with values, which will generate noise, but it sounds like drum stuff. And now you can play kind of drum. So yeah, you are using math to reproduce sounds. It's like pretty synthesizer stuff. And if you use the same exponential stuff on the amplitude and on the frequency, which will generate a Doppler effect, it's kind of a laser gun. I'm sorry, not the laser gun. There you go. So you see the difference between drums and a laser gun is basically Doppler effect. But if you know other equations, you can even like emulate a violin. But yeah, so yeah, arrays can sing for real. But now, if color are arrays, and you can play whatever you want inside an array, can we hear a color being played? Like, let's imagine that we grab the red color from the cover and play it. So this will be way worse to your ears. So here we go. Okay, I'll stop it. So yes, you can hear a color, but this will not be the worst thing that you are hearing today, I assure you. So just mind that you have the zero, the image values, the colors are 0 to 255, and audio are close to 0, like -1 to 1. So you need to do the math to go from one to other, but yeah, it's simple. And let's talk about filters. Filters are useful things, and the audio filters. This is a low-pass filter, so you are removing the high frequencies as like depending on the value. And yeah, if you remove a lot of the high frequencies, you have this sound that you are hearing, but it's pretty nice. And you have the high-pass filter where you can remove the low frequencies. And if you notice, it's like if you remove the low frequencies of a sound, it's like really crappy. So if you have a drummer, a friend that is a drummer or bassist, like you need to give credit to these people. But so if you look at the input in orange to the output in white, you see that the low pass filter is removing the shifts from the fast transitions in the signal, and you're basically doing a smooth. And like, let's now grab the colors from this cover one by one and pass through a low pass filter, like as we did with the other examples. And basically, if you do this and reconstruct the image with the outputs, you have a blur effect. And if you think like in transitions, you go from like values in pixels. If you do a smooth there, you have a blur. And the high pass filter, you remove the low pass components, so you have only the fast transitions. When you apply that to an image, the only thing that you have is the edges, because the transitions from like some values in color are basically how you have the objects on the image. That's the reason why you can see that much on the sky, but you have the colors, and the coat is easy to see because you have many color transitions there. So you can see that that these filters works from audio to image, like math works to both. As I promised, the color being played will not be the worst thing, because you will hear me to play guitar, and that's like pretty bad experience. But I want to thank Sam Ballant. He did a JSConf Budapest talk about audio effects, and really inspired me to try not only filters, but how images will be affected by other stuff. First example is like, let's introduce a delay between like the input and output. And this is not really useful if you think about how things work to musicians, because you want a feedback that you are playing. If you just do this, you're just shifting the signal, and it's not really useful to have something that you play and you have the feedback later. So, but not useful to sound. But when you do that, like if you see the input versus output, a delay work as supposed to be, like you cause a time shift. But when you apply that to an image, you have a shift, like you have this change on a surface, like the canvas surface. And you are basically pushing the image away. And if you add a really big value, you like start to lose the image, start to go away. But yeah, it's kind of fascinating how like it's kind of a debugger. And one thing that you can do is like to add a direct path from your microphone to the output and add a different path to the delay. So now you have something that you can use to play. And you can hear the original signal and the delay part. And when you apply to the image, you have like the original cover, because you have the original path, and you have the phantom being like the delayed signal being together, like with the shift. And the nice thing is like the points where you have these overlaying, the values are like the images are like more, you have the color being enhanced, or I don't know. So depending on the value of delay, you have the second image being placed like right next or far away. And you can use the same delay, but add a gain node here, and you reconnect back to the delay. So you create a loop structure, and it's pretty cool because you can have these. You have this infinite, like it can be infinite, but you have this loop structure. And as you can see, you have the input is just 2 oscillations, but the output, it goes on. As you can see, it works the image as you have like a lot of images being placed. And it's kind of nice that are being placed like, you can see that there are some that are really close together here because the value of each oscillation is being placed like with the same time shift, and it's pretty nice to see this effect. And here we have the Flanger one that's pretty. It looks pretty complex. You have a delay here that are being retrofeeded, like you have this loop, and on the other path you have the oscillator that are being connected to the same delay, and that will give you this oscillation vibe. And this will give you this, the note keeps oscillating because of how oscillators work. If you apply that to an image, like this is the original signal in orange, and you can have, depending on the values, the yellow one or the white one. So it can change the, like how many repetitions you have or how it will behave. And the cool thing is, like, you can see the oscillation being applied, and you can see the original signal because you have a direct path between the microphone and the output. So you can see the image that are not distorted, not like vibrating here. So it works almost as a debugger. This node is called Convolver, and this is very used to do a reverb effect, and it's pretty nice because you basically give this node a function, or like an audio input that says basically, I want you to behave kind of like this audio here. So in this case, I stole this from Sam's talk, probably. I'm pretty sure that I am. But the guy clapped inside a church, and he recorded that. So this clap is like being reproduced here. And if you see the original signal and how the phase are being affected and amplitude and everything on the signal, basically, you can see why the output is this. Like you have the oscillations, you have amplitude being like, so you have all the properties being like changed. And this, if you ask me, this will be a pretty cool chart. But the last node that I want to talk is the wave shaper. It's used to do distortion, and depending on the curve, you can input a curve, and depending on how is this transition to this 0 point, you have the faster is the transition, the more distorted it came. So you have the white one, you can think in Rolling Stones distortion. The yellow one will be AC/DC. This one could be Metallica, and this one Sepultura. And you probably are thinking, I know way heavier bands than that, and I know that they exist, but I can't go there and discover what it means. I just kidding. I know Cannibal Corpse and all of that. So just like, this is a font, something that I find funny. But so let's start distorting less. Or we can distort a lot. So and you can see the effect here. You have the scene function, and depending on how are you distorting, you can have the yellow or the white one. So it will start to become a like square wave. And this is pretty cool, because when you apply to an image, you see that it's affected in the way that you are like rounding some of the values. And when you do that, you are sucking the color from it. So it's like the heaviest the band, the darkest will be. This is kind of mind-blowing. It's like metal stuff. So I will spare you to hear me playing guitar, which is like, will be a relief. And this is, I was wondering if I could do 8-bit vibes using web audio. And here is a song that's not David Bowie. I hope you recognize. I basically grabbed the original signal that I was playing the snippet on guitar, and I was rounding to like specific values to have this 8-bit stuff. And one thing that you do when you apply this to an image, you have pixelated stuff. Ignore that you have shift, because that's just the node taking time to process. But if you see here, you have pixelated clouds, and that reminds me of the pixelated clouds of Gunstar Heroes. And I know that's not 8-bit, but I was pretty proud, because you can use the effect to apply the music and to generate sprites. I don't know. That was my take. It's the message is like, don't do this in production, but it's funny to do for like just because we can. But my take here is like, our community need to embrace diversity, like Bowie was his like main message, I think. And let's understand that people are different from me, the white man in IT. And I think that we should be more like we gave some steps, but like I don't want to just throw stuff here, but we need to embrace diversity. And yeah, that's it for today.
Amazing. Nice. Yeah, so here, let's switch to this mode. Yeah, that was super cool. Can I just ask you just a couple really quick questions about the talk, and then we'll go and see if anyone in the audience has questions. So by the way, if you're watching this stream, now's the time to type your questions into the chat, and we'll ask Rafael whatever you want to know. So yeah, my quick question is just, you can use any image you want, right, as an input image?
Yep. You can.
Okay.
I was just grabbing the Earthlink because there are all colors. That's how it's.
Okay, so that's just a good image because it really represents the shifts that happen.
It has blue, red, and green there, so it's really great image.
Okay, and then the input that's coming in from the guitar, was that using just like a line in, like just the microphone input on the machine?
Yeah, I have a Focus. I'm sorry, they are not paying us to announce that, but I'm using a USB interface, like to grab the signal from my guitar, and that's basically going to direct it to the browser, and that's it.
Makes sense.
Nice.
Do you have any questions, John?
Well, yeah, a few. First of all, this reminds me, like the filtering stuff and the distortion reminds me a lot of working with analog TV, because it's just like treating the it's just the analog version of treating everything as a number and then processing it through. So I gave a talk a few weeks ago on Speakeasy about my antique TV, and a lot of this feels very familiar.
Oh, it was you. Yeah, I was not associating that one. Like, because I saw the thumbnail, I was like, wow, this looks interesting. Nice.
Yeah, no, I really like this, your demo. You know, I kind of want something like this that I can just play with, like interactive, change the graph and see what it does to the image. And I did have one related question. I've been looking at some oscilloscope music recently, which is like not the same as what you're doing. That's you're talking about processing images like sound, and this is sort of the opposite. It's taking sound where you take the left and right channels and you plot the position as in the right and left voltages, the audio values as like an XY plot. And I think there's a lot that that people could do with that to make really interesting art. I was wondering if you have any thoughts on that.
There is a lot of artists that goes like they use P5 sometimes, but they are like use images to sounds to affect image. I play around a little bit, but I wasn't getting much interesting results because I didn't explore that much. But one thing that I was doing is like get a sound and render in canvas, and you basically have like old TV noise because the values are very close to each other, so it's like everything is gray. But yeah, there are many artists on the JSConf Europe. They have this Live Network JS. I don't know if it's the right handle, but you can search for like Ruth John Twitter handle, and she does like really amazing experience. But there are many people into doing these crazy experiments, and it just looks really nice.
Cool, I'll check that out. Yeah.
Yeah, I'm forgetting the name of the group too. The group name is Noise something. I think it was like Noise, and I forget the. Okay, we'll post it maybe in the chat if you remember the group name.
Yeah, you might be able to get the audio to look better in the canvas if you somehow like detect some part of the signal to like start the next line. I bet there's something that would work there.
Yeah, I was about to do something with generative art that like basically you have something that are all, if you have this like a lower tone here, let's if something happens in a specific time, let's draw a square, for example, and then you have these combinations where you can have like music generating art in this process.
Yeah. Cool.
So let's go to the chat and see what questions people are asking. So we have one here from Tiny Fluff, who was asking why not use it in production.
The way that I did, I was grabbing the array and passing through the node, and the thing is like the node still think that is audio. So depending on the size of the image, you will take. Let's see that you have an image that the arrays will have, I don't know, 44,000 and something size. These will take a second to be processed. So you are basically like using something that are not this quick. But as people suggest me to use background, I don't know if this is the correct name, because you can use an offline web audio API, and you can use it to process sound like instantly. And it's really not something that it's more performatic. It's just cool to see it, and that will eat the memory alive. So like this will be a pretty dangerous stuff to do in production. Your user will be like really mad with performance stuff related.
Mm-hmm. So the next question is from, I don't know how to say the name, but they're wondering, they're curious in making to make similar experiments with the Web Audio API, and we're wondering what the best resources are for people to study or tinker with. Do you have any recommendations?
There is a pretty good book, if I can remember. It's like it's from O'Reilly. I think that has a bat. There you go. It's by Boris. Let me paste it in the chat. And I think this is now. You have all the examples that are. I don't know if it's free, but
just paste it in the private chat, and then I'll paste it for everybody. Cool.
Thank you so much. And this book is like a good starting point, but the Mozilla documentation is pretty good. And the thing is like sometimes there are some stuff that is just pushing. This talk is like I'm grabbing examples from like 4 years ago, so I was like trying to do some stuff for a long time, and then this is a collection of really old demos. But yeah, it's that would be my suggestion. These to restart and then to learn more about, because I am graduated in telecommunications, so I have this like background of understand signals, and I try to reproduce some of the behavior from there. That's it's something that I took a lot of time to learn, because it's not easy. The Fourier transform and all of that, it's like takes some time to learn. It's not that easy, but I will be. You can tweet me, and if I find better resources, I will be glad to help.
Cool. And then we have one last question here. Tiny Fluff again asking, is it possible to stream an image through the audio APIs? I think they mean like straight up take the image like without any processing and just play it.
I think that you still need to. To grab the images as an array. So at least you need to go through the Canvas API and grab this information. So yeah.
Right. That makes sense. So you couldn't. I mean, but you, in theory, could you like not even like use Canvas and just take the actual bytes in the file and see what that sounds like? Probably would be like not as interesting of a sound, maybe, but I'm curious.
That would be interesting. I never because I was just using Canvas as like a way to grab image information as an array. So that would be cool.
Interesting idea. It looks like we have one other question in the chat. Have you tried going the other way, like audio to spectrogram to WebGL shaders for typical image processing operations to audio?
Yeah, I didn't like have grab audio then do a spectrogram. I don't like I never played too much with WebGL, so I didn't. I was trying to prove that you can go to images and like process as audio, and like the other way, like to render a song in Canvas and try to apply a pure image filter, grab the song again and play it and see if it will sound like something that is processed. But I don't know if I didn't use the right filters, but it doesn't work. Because one thing that I learned is it's pretty easy to mess up sound. Like if you have a glimpse, like if you have a really fast transition in a song, that will hurt a lot in your ears. Like it's pretty, the noise in sound is way painful, because if you see a totally screwed up image, that will not hurt you that much, but your ears doesn't work well with crappy sound, as you can hear some bands around that. Just kidding, but yeah, it's hard. The other way is harder.
Cool. Well, that was super cool. We never had anyone well, we have had someone come on Speakeasy and perform like a live music set, but never anyone play guitar and with the visualizations and all that. So this is the first and super cool talk. I think we both enjoyed it, and hopefully all the viewers did too.
Yeah, this is a lot of fun.
Yeah, that was great. And if I can like say that to people, is like go through the previous talks. There are like the Substack one on the TV emulation stuff is really cool. So yeah, thank you for having these conference stuff going on, because I miss so much.
I put up the URL for the previous talks if you want to check out the Substack talk that Rafael just mentioned. It's on there. You have to scroll all the way to the bottom because it was one of the first talks. But yeah, that was a really cool talk. The slides in that talk were all like just like processed by the same system he was talking about in the talk, and it all just looks really cool, really neat.
Yeah, that one was a lot of fun.
Yeah. Cool. Well, with that, then I'll just say thanks again, Rafael, for your talk. Glad to have you. And everybody will be back here again next Friday at the same time for another talk. And if you want to hang out and chat with the speaker and John and I will be on the social happy hour website, which I'll put up the link for right now. So if that sounds fun to you, we'll be there for about 20 to 30 minutes hanging out, and you can come hang out with us and chat with the other attendees. So cool. Thanks again, guys. Catch you later.
Thank you so much. That was a real pleasure.
Yeah, thanks again, Rafael.
Thanks for coming.